I wanted to go through a sample problem with you. A sample problem. So in this case, we would say that at a particular temperature, because remember temperature changes wave speed, at a particular temperature, say whatever today's temperature is, the speed of sound is 345 meters per second. It's usually between 335 to 355 meters per second, depending on the given day and the weather and the humidity and things like that. That is equal to approximately 760 miles per hour, if you are curious. And let's pretend that this sound is broadcasting a frequency of 880 hertz, and we want to know the wavelength. Okay, so we're going to use our new equation. Those are our givens and our unknown. Our equation is going to be V times wavelength times frequency, where V is 345. The wavelength we don't know, so we're going to leave it alone, and then we're going to substitute in 880 hertz. Then we're going to divide both sides by 880, and we get our wavelength of, I already calculated this. If you put it into your calculator, that would be 0.39. Oh, that's terrible. 0.39 meters. Okay, so that's your typical Wavespeed problem. They're not typically too difficult. The one thing that they will sometimes do to throw you off is they will give you the period instead. So you might get a word problem that says something like waves at a beach hit the ground or hit the sand like every 3.4 seconds. So we've got the period. Anytime it's measured in seconds, a wave is occurring every 3.4 seconds. That is the period in this unit. So time is measuring the period. And let's say the tops of those waves. So if we've got like, these are my very artistically accurate waves. The tops of those waves, we'll say, are 15 meters apart. And so the distance between two waves would be the wavelength. And then again, we're trying to find the wave speed. And you could cheat if you remembered the formula that we used to derive our wave speed equation. But imagine 3 weeks from now, you won't necessarily remember that. So you only want to use equations that are on the equation sheet to prepare yourself for later in the unit. So we have this equation. This is how we calculate speed. And I have the wavelength, and I'm looking for velocity. That's actually the only this is the only equation that has both those variables in it. So it has to be this equation. But I don't have the frequency. So then I would look at my equation sheet and say, okay, I also have the period though. Is there a way to get the frequency from the period? It turns out there is. The frequency is 1 over the period. And if we plug that in, 1 over 3.4 seconds, we get a frequency of 0.29 hertz. And then we can plug that in over here. This is 15 meters for the wavelength, which we got from our handy dandy picture. And then 0.29 hertz for the frequency. And then we would multiply those out, and we would get an answer of 4.41 meters per second. Okay, so it was a little bit of a two-step process in this instance. And that's one of the ways in which they can sometimes try to throw you for a loop a little bit, because you have to use 2 equations. And then sometimes the other thing they might do is they might give you a graph instead of givens. So you have to pull the information from the graph yourself. Okay, so let me draw a graph really fast. sound effects are required. So my y-axis is measured in meters. My x-axis is measured in time. We will give this an amplitude of, like, say 5. And then I'm going to say this is counting by 2s. You always have to look at the 2s, Miss Brown, 2s. Okay. So I also want to, so from this graph, the things they might ask you to find the amplitude, the frequency, the period. I want you to realize you cannot find the wavelength from this graph because the axis is measured in time. So I can find the period, but I cannot find the wavelength. Okay. So to get the period, it is 1 up and 1 down, which would go from here to here. So the period in this case is 4 seconds. That's not a 45. That is an S. You could also go from peak to peak. If you did peak to peak, you'd have to realize that this is a 1 and this is a 5. So you do 5 minus 1 and you would get t equals 4 seconds. So again, whichever one you use, if you go 1 up, 1 down, we got 4. Peak to peak, which is more intuitive, but you have to actually do some subtraction there to figure it out. We got the same answer. So whichever one you use is totally fine. So I've got a period of 4 seconds, which means my frequency is 1 over t, which is 1 over 4, which is 0.25 seconds. I can also get my amplitude from this, which is the height of my wave, remember, from the equilibrium position. So this is A. If I go over here, I said earlier that we were just going to make that 5. So we've got our frequency, our period, and our amplitude. Okay, so that was all information that I could pull from the graph. And the problem might say something like, if the wave speed is 60 meters per second, okay, so if the wave speed is 60 meters per second, what is the wavelength? Because remember, we can't get the wavelengths from the graph. So if they give you a graph and they ask for wavelength, chances are you have to get the frequency from the graph so that you can get the wavelength. Or it's the other way around, where you can get the wavelength from the graph if this was measured in meters. And you could use that to then plug it into the equation and get frequency. Okay, so you can do that in different ways. So we're using our new equation. We're plugging in 60 meters per second for V. Our wavelength is what we're looking for, and we got our frequency earlier. Oh, I put the wrong units earlier. This should be in hertz. That's in seconds. Hertz is inverse seconds. And then frequency is 0.25 hertz. We are going to divide both sides by 0.25. 0.25. If you're dividing by 1/4, it's the same thing as multiplying by 4. So 6 times 4 is 200, or well, 6 times 4 is 24, and then we've got a 0 there. So that becomes 240 meters is equal to our wavelength. Yay! All right, and so those are the 3 types of problems that you might have to do with this kind of situation. You have a assignment, Wavespeed practice problems. That is the 3rd assignment this week. That is after your Wavespeed lab conclusion. That's due on Monday, March 23rd. If you have any questions or need help with any of the problems in this assignment, please, please, please email me or text me using the Remind app. There are directions in Canvas for how to do that. See you soon, hopefully.